My name is Tanner, and this presentation is cross-chain swaps and beyond with 1inch. I am a developer relations engineer at 1inch, and let's get started. So today we're going to be talking about classic swap, which is what most people probably know 1inch for, which is our AMM and PMM aggregation. We're going to talk about 1inch Fusion, which is our intent-based swaps. And we're going to move on to 1inch Fusion Plus, which is cross-chain swaps. And then we're going to talk about integrating these into your projects. So a quick little blurb about 1inch as a project and its origin story. We started as a hackathon project in ETH New York in 2019. And since then, we have grown to over 3 million users, over $55 billion in total available liquidity. We have processed over $500 billion in volume through our routers, and we currently hold around 38% of the aggregation market share. And that's about double our next closest competitor. So it's still a very strong position in the market. So let's jump in and talk about swapping with 1inch. So here are all the chains that we currently support. There's 12 of them. This is supported for both our aggregation as well as our intent swaps and cross-chain swaps. There is one exception to this, being that these 12 are EVM-based chains, and we have also recently launched on Solana, which is our first jump into non-EVM swapping through 1inch. Only on Solana is Fusion. There's not aggregation or cross-chain, but hopefully that will be coming in the future. Right now, this is all we have, and we're going to talk about more non-EVM implementations a little bit later in relation to the hackathon. So let's start with classic swap. Again, this is our aggregation. This is what people most know 1inch for. So it's aggregation of on-chain swaps. So we source liquidity from all popular protocols. We combine these protocols to optimize a swap output for the user. And we execute all of these swaps in a single transaction. So let's go through an example. Let's say that some new user comes into Ethereum and they want to swap USDC to DAI. They will likely take their USDC and put it directly into Uniswap and get their DAI. And that's fine. That's what most people do anyways for a lot of their swaps. And I still think they hold something like 50% of the DEX market share. So this is what most users will do. But let's just pretend they are a little bit more sophisticated, or their friends are more sophisticated, and they say, oh, you should use an aggregator like 1inch. Their USDC will then go into the 1inch system. It will then use our complicated pathfinding algorithm to find the best place for that USDC to be swapped to DAI, and likely still choose Uniswap, because just a lot of trades really do actually go through Uniswap. But let's pretend that maybe they have a very, very large amount of USDC, or they're doing some token pair that isn't so common, like stable to stable. Now you get to see the benefits of our aggregator, which would be maybe splitting some of the trade to go through Dodo. Maybe it does a intermediary swap to Tether through Curve, and then take that Tether and put it through SushiSwap and eventually get to the DAI for the user. So this will get as complicated as it needs to be to give the user the best rate. You might be thinking, yeah, the gas cost will also go up as you add more complexity, but we factor this in as well. So we're going to do what has the best total output for you. So if that means adding more complexity because gas is cheap, or if that means using a single provider because gas is really expensive, we will take that into account when we are making that decision. So let's go back to the simple example of going through Uniswap for a simple DAI transfer, or USDC to DAI swap. Let's compare these head-to-head and actually look at the gas efficiency of these. So if you just go through Uniswap directly, you'll use about 205,000 gas on Uniswap v3. And if you do the same swap but go through 1inch first, you actually only use about 175,000 gas. So even in cases where you're doing the most common use case for swaps, it actually is still cheaper, because we knew that we could actually out-optimize the Uniswap router and save gas there. So even in these common use cases, totally worth trying us. In the end, aggregation will probably be how most token swaps happen. So let's jump on to 1inch Fusion. So in this system, a user submits a swap request with a signature. A Dutch auction is created for the swap. Resolvers asynchronously compete to fill that swap. Users are protected from MEV by design. And finally, it is a gasless transaction for users. So there's a lot in there. So let's break down some of what we just talked about in that slide. So what is a Fusion Dutch auction? Or more broadly, what is a Dutch auction? In a traditional auction, you start at some low price and you go up until there are no more bidders left, and that's the final price that is used to sell an item. In a Dutch auction, the opposite is used, where you have a very high price, or maybe something slightly above what they think the market rate is, and that will go down slowly over time until a single person says, okay, I'm interested in that price, and then that is the end of the auction. So it kind of inverts the traditional auction model to come up with new approaches to selling things. The next one is, what is a resolver? These are counterparties inside of the 1inch Fusion system that are going to be the people actually doing the trades. So in this system, it isn't just AMM swaps with you posting transactions on chain. It's signatures and counterparties trying to give you the best rate they possibly can by competing with each other. So let's look at a really simple chart here. This is like what a Dutch auction kind of theoretically looks like. You have time on the x-axis and rate on the y-axis. And that first dot at the very top left is going to be the maximum price that the user can get for a swap. And it will slowly inch down over time until it gets to some minimum price. And along this curve, ideally, a counterparty picks this up and finishes the swap for the user, or does the swap for the user. So let's go through a diagram and actually talk about what's going on here. So a user says, okay, I would like to swap 50 USDC for DAI in the Fusion system. We will estimate somewhere around 50 DAI because it's a stable coin to stablecoin transfer. The user will then sign this transaction and they will send it off to the 1inch API. The 1inch API will then post this transaction into the internal Fusion system and it will start the auction. So let's say this is a 3-minute Fusion auction in this case. This information will then be propagated to all of the resolvers in the system who are trying to watch and see what's going on. And every block, each of them will decide, hey, do I want to fill this or do I not want to fill this? In most cases early on, it will be a pass because it's going to start at either market rate or just above market rate. But eventually, there will be resolvers that say, okay, at this rate, I can take this swap and actually make profit from it in some way. Now, at this point in time, since these are actually done on chain, this can be a competing situation where two resolvers say they want to fill this auction at the exact same moment. And in this case, it's just a gas war. It's just who pays the most for the auction. But there's also the option to do partial fills. And if you do a partial fill, there are scenarios where both resolvers can actually fill this auction as long as they don't go over the total 50 USDC amount. This will repeat until all of the USDC has been swapped. So here's a much more complicated chart showing a real swap that happened in the system. This was 3,700 WETH for USDT. And the curved line at the top kind of slanting down is the price where the fills were happening. And the dotted line that's straight across in the middle is the market rate. Each of those dots along the top is where a resolver came in and did a partial fill of this massive swap. And by about the 4-minute and 48-second mark, all of the partial fills had completed and the whole swap executed at slightly above market rate. So this is a massive swap and something that probably no aggregator could ever do because you're actually beating the market with this approach. And this is why long-term intent swaps will probably be the way that most swapping happens. And AMMs will have maybe a niche market, but intents will kind of be where people move to long-term. Okay, the question you might be wondering is, where are these resolvers getting this liquidity to do these swaps for users? And the way we design the system is that's really up to these counterparties. Maybe they have some sort of connection with a SEX. Maybe they have a personal funds that they're using. Maybe they have found some arbitrage opportunities in a DEX. Or maybe they're doing something clever with cross-chain. It's really up to these resolvers on how they would like to get this liquidity to execute these trades for users. Okay, on to Fusion Plus. So when we were building Fusion Plus, we tried to ask ourselves what matters for users when it comes to cross-chain. We know that we need good swap rates because people are going to go to wherever they can get the most efficient trades. And we know that people also really like simple UX. And the last one that we thought was really important was to try to make a system that's as trustless as possible, right? Because bridges are kind of complex sometimes and they don't have the best UX. So we really wanted to make sure that the design itself was going to actually be cryptographically secure, not try to come up with maybe an incentivization, to be honest, but actually like build it into the protocol and design itself. And what we ended up landing on was hashed time lock contracts. Hash time lock contracts are simply smart contracts that hold funds, and they require some secret S to unlock the funds. And after a certain amount of time, they'll expire if that secret is not provided to them. So you either provide the secret and unlock the funds to the final destination, or they expire and the funds can only go back to where they came from originally. So let's look at another example. So we have a user here, and they have some secret S, and only they know this secret S. They will hash this secret, and they will create one of these escrow contracts using the hash of the secret. So it's not the actual key, it is a hash of the key. If someone else goes to this contract and they try to get the funds out of this, let's say in this case it's Ether, they can't do it. The transaction will not succeed. But once the user shares this secret S with somebody else, they can interact with this contract. The contract will run the same hash, validate that it is the correct secret key to get access to the funds, and then those funds are unlocked. So that's the core design around how our cross-chain swaps actually work. So let's go through another example similar to Fusion. You say I have 50 USDC on Ethereum, and I would like to swap it to 50 DAI on Base. You sign the transaction. You send that off to the 1inch API. The 1inch API then starts a Dutch auction. It says, hey, there's 50 USDC. We would like to swap it to DAI. And they send all of this information out to the resolvers just like before. Same thing happens. People are competing to see who actually gets a chance to fill it. So let's just keep it simple and say that one resolver took the entire auction. And now we get into kind of the execution phase of this swap. So Resolver 2 has now kind of claimed rights onto this swap, and they will start building out these escrow contracts that we talked about earlier. So they will build an escrow contract on Ethereum, and they will deposit what we call a safety deposit. And this is a financial incentivization to make sure that the funds get released at the end, whether that's releasing to the Resolver 2 in this case or releasing back to the user. We just want to make sure that the funds don't get trapped in the contract. So to kind of create this whole contract at the very beginning, you need to put in the safety deposit so that it makes sure something happens at the very end. They will also create the escrow contract on the destination chain, in this case, Base. They will then use the permission that the user had originally granted to the Ethereum router or to the 1inch router, and they'll move that USDC over to the escrow contract on the source chain. And then Resolver 2 will then fund the escrow contract on the destination chain. So at this point, now we have 50 USDC in the Ethereum escrow contract, 50 DAI in the Base escrow contract, and the next phase of this swap can actually happen. And that comes in, now comes in the relayer. So the relayer is a service that is watching both of these escrow contracts. So they're watching the source chain, they're watching the destination chain, and they're waiting to see that everything is where it's supposed to be. Once they see that the correct amount of funds are on both of these contracts, it waits a small amount of time to make sure that there is no chance for a reorg or anything like that. And after that period goes through, then they basically announce to the rest of the system, hey, everything looks good. It's time for the user to release their secret so we can complete the swap. So at this point, the secret is finally released from the user. At this point, it has never left their computer. It is just sitting there waiting to hear the message that the auction, that the escrow contracts are properly funded. They send this information to the relayer. The relayer then broadcasts this secret out to the resolver, as well as every other resolver, even the ones that were not part of this auction at all. And the reason for that is, again, what we talked about earlier, where we want to make sure these funds don't get trapped. So Resolver 2, in this case, since they were the one who claimed the auction, will have a small amount of time where they can be the ones to release the funds, and they will get the safety deposit that they had originally deposited into these contracts. If they do not do it during that exclusivity period, they will then lose those rights, and anybody can do it. So Resolver 1, Resolver N+1, anybody who wants to finish off this transaction will then be able to claim the safety deposit. And this design is not limited to just the EVM. That's what we talked about earlier with kind of starting to look into Solana, and that's what we're actually focusing on with this hackathon, is we want people to build this system, but for chains outside of the EVM space. So Sui, Aptos, anything like that, anything you guys are comfortable with, this is something that can be done today using our official escrow contracts and that design, and it can work already. So this is something we want people to build. Okay, so on to the next section of how do I actually integrate 1inch in my project generally. So the way you actually interact with 1inch is through the developer portal. And the developer portal also has pairing SDKs to make this as easy as possible. So let's talk about the developer portal. This is the official hub for integrating 1inch into your projects. This is where you're going to get your 1inch API access keys so you can talk to all of our REST APIs. This is going to be where you get documentation for all of the APIs, well, swap APIs and other APIs, as well as examples. You go to this website, portal.1inch.dev, to get started. Don't worry about writing any of these down. There will be a QR code at the end that will link you to all of this stuff. And we'll just take a quick look at what the website looks like. You get here, you sign up, you get access to a dashboard, which I think it's a little blurry, but this is the dashboard where you can see all of your API keys, requests, summaries of what you were doing. as well as get access to all of the documentation. So this is Swagger documentation for all of our various REST APIs, so you can figure out what you need to do to interact with our system. Okay, let's talk about the one-inch SDKs briefly. So we have multiple SDKs that simplify the interactions with our APIs. For most of our APIs, it's pretty straightforward. Like, you don't need an SDK, but for swapping with things like Fusion, there is actually a ton of call data that's generated, and it would be really hard to do this without the SDK. So I would consider this critical infrastructure if you want to integrate with our Fusion system at all. These are written in TypeScript and Golang currently, but they're going to expand to more languages in the future. And when you are building with the one-inch API, it's very, very important to know that when you make requests from the front end, you have to use a proxy. If you don't use a proxy, you'll get a lot of confusing errors, and it might not be very clear what's actually going wrong, but let's talk about it briefly. So if you have a front end and you say, okay, I would like to call out to the one-inch REST APIs, this will just straight up fail. You'll get a CORS error, I believe, and it's not like, it doesn't really explain what's going on, but it's basically saying, we don't want you leaking your API key to whoever's connecting to your website. So if a user's on your website and they are making a request to the one-inch API raw, they'll also see in the headers your API key. So a proxy is going to be how you protect that. So what you actually want to do is front-end request goes through a proxy. Proxy then attaches your authorization token, and then that's what eventually will be sent to the one-inch API. And then obviously the smart contracts from there. So I created a really small repo just to make this simple for hackers who want to actually use our APIs without figuring out how proxies work, in case you aren't familiar with that. This is a cloud-hosted proxy, and it'll work with all of our one-inch APIs. Again, don't worry about the links because you'll get them at the end, but feel free to take pictures. It has a nice README. It uses Vercel. You have a free tier on there. It's completely free. It's as close to a one-click setup as a proxy could be. So this is the way you want to do it if you're using our APIs at all. And then lastly, we will quickly talk about just the more general API suite we have. So you can get token price data, wallet balance data, even NFT data. There's a lot of infrastructure that we built out that we publish through our REST APIs. So if you're doing anything at this hackathon and you want to just get data that's not being pulled from an RPC directly, we have probably a good chance of offering that data for you. So that's something else to be aware of. Okay, last, let's talk quickly about the bounties. So as I discussed earlier, non-EVM extensions for one-inch cross-chain swap, which is Fusion Plus, that has $12,000. The top 3 projects will get their share of that. We are also asking for people to build on limit order protocol. We didn't talk about that in this presentation, but come to the booth if you're interested in order books, CLOBs, or limit orders in general, and we can talk to you about what we have built and what are some ideas that you guys could build on top of that. We've already heard some cool ideas from people coming by the booth today. And the last one is to utilize the one-inch APIs, and that is for $1,500. So yeah, that is everything for me. Not portal.oneinch.dev. Yes, this is the QR code. This is a link to hackathon.oneinch.community, which is kind of the hub for accessing everything to do with the hackathon this weekend. This will also give you an API key so you can get unlimited access to our APIs. So if you're doing anything with one-inch this hackathon, start here, get your API key through the flow that we've put up for the hackathon. And yeah, thanks guys. Any questions? I think we have time for like one, if anybody has a question. Yes.
You had this chart where somebody sold like a 1,500 ETH.
Yes.
Above the market price.
Yes.
Over the course of like 4 hours.
4 minutes. Between 4 and 5 minutes. Yes.
Okay, already better. So you're saying that resolvers find ways to make money somewhere somehow. And
yes.
That's how they. Could you maybe elaborate on it? Like how does it work? How it seems like magic.
Oh, I have never done it myself, but you can think of things like maybe there's a price discrepancy between 2 centralized exchanges or 2 decentralized exchanges, and they've found something that's a unique way, maybe with I'm not one of those resolvers, so I don't know how they do it exactly, but arbitrage would be a good example of where people find ways to inch out a little bit of money. I mean, some of these resolvers will do a very large swap and they'll make like $5, but that's still $5, right? And then once you get to the volume that we've processed, which at this point is around 500 billion, like you can see how even a couple, basis points that you're making on these swaps, even if it's just pennies, it will really add up over time. So that's my best answer for you right now, but I don't know exactly all the creative ways that people do it, but I just know kind of high level.
Hi. I can explain a little bit more deeply. So the thing is, especially for higher amounts, we can organize more because we let market makers to compete between each other, and we try to sell on a spot price. So when you exchange, especially bigger amounts, you face a price impact. So you get actually not at the rate of spot price, you get actually an universal rate because liquidity is limited, and especially liquidity is very fragmented. You have on base less liquidity for example, ETH USDC pair. On Ethereum, you have better liquidity. If someone swap on base, then arbitrage traders potentially will arbitrage, market makers will arbitrage from Ethereum blockchain into base. They don't do it like in this time. They have balances on different blockchains. They maybe buy your Ethereum or sell Ethereum to you and do the reverse trade on the other platform. It can be like other blockchain, or it can be centralized exchange. That's why kind of we can organize more. So, and the Dutch auction gives the opportunity to sell the user order to the market makers over time. For small amounts, the settlement is in a first or second block. Yeah. For bigger amounts, it can go over minutes. But it generates more. We have real world example. I don't know what did you show. I came a little bit late. Real world example: 12 million USDT to Ethereum. This guy who did exchange on 1H got 200,000 US dollars more. So this is like a new 911 turbo. Well, they got free because of using our tech. So yeah, arbitrage opportunity is always there. Some market makers also have things like, okay, I need now to sell for a customer a lot of Ethereum. Yeah. So and they have the chart. Did you show the chart?
You're talking about the gigantic, the 3,700.
Yeah.
Just keep going back, you'll find it.
No.
It's a ways. Here, I'll get it.
Yeah. So when market makers compete, they settle. In my presentation, I have another normally, but yeah, you need me to check. So you see the first point in this chart is the spot price. Middle here, or yeah, here, not in the middle, almost. This is the market rate. The difference between the spot price and the market rate is the price impact, what the user see. The market rate you get when you do classic swap, so not intent-based swap. Classic swap is when you ask an aggregator to provide call data with the complex path, how to exchange one asset against another. And you do the transaction by yourself. So you face this price impact immediately when you do the transaction by yourself. And we can reduce it. Yeah, the spot price is actually, yeah, it's what you see on the centralized exchanges, but you have always a spread in the centralized exchanges, yeah? And the spot price is like, yeah, the last traded price, but it's, you know, the liquidity is very thin, yeah, and
So am I correct that the seller here got the price somewhere between the
spot price and the market rate?
The fast market price, the spot price on centralized kind of, and the market price on the blockchain if they do this trade just in a normal manner. So they're like in between. So they're not actually beating the market, but they're losing less than they would if they did this on chain naturally. Is this correct?
It's like that. Like if you think.
Can you guys do this like off directly?
Okay, we are okay.
You guys can.
All right. Yeah, we can discuss afterwards. So, like under the hood, we just try to reduce the price impact when someone exchange assets, especially for bigger amounts. We pull the liquidity from everywhere, like that.
All right. Thanks, guys.